Okay, so back to mirrors and lenses. At some point, when it's permissible, I'll send you these notes. Okay, so what we have so far is that light travels in a straight line if the medium is of uniform density and if they don't strike a reflecting surface. And so what you wrote down was they travel in a straight line unless they strike a reflecting surface or the medium is in uniform or changes. If one of the two above things isn't true for the printed notes here, or is true for your notes, then the observer will see an image of the object that's at a different position and or may have different size than the actual object. Okay? An image is formed where the light rays originated from an image is formed when light rays originating from the same point on an object intersect or appear to intersect, and that's the part I wanted to talk about. So just as the last video ended, I was saying if you have an object right here, then a light ray leaves, it goes in. If it strikes the mirror right on, it'll come straight back. If it strikes at some angle, it'll get reflected off at an angle that's the same. Remember, the law of reflection is angle of incidence has to equal the angle of reflection, and it's always measured with respect to the normal. So, but these light rays that are reflected are not going to intersect here. You actually have to follow them back to see where they'll reflect, and they're going to reflect back here. And so that's where the image will be formed. So when you're standing in front of your bathroom mirror, you see your image back here because that's where the reflected rays appear to intersect. And so that's what we mean by where the light rays originating from the same point on the object intersect or appear to intersect. These guys don't really intersect, they just appear to. So in that picture I was drawing, sorry, pin cap, I was drawing, right? If this is your head, then light rays would seem like they're coming from here. This gets reflected off like this, and they'll appear to intersect back here, and so your head would appear back here. Okay, so they're not really intersecting. All right, so we have two different types of images, real and virtual. And I said at the end of the last video that you'd be most used to virtual images. So make a little chart, real, and virtual. Okay, for real images, the light rays from a common point pass through or get reflected from, pass through if it's a lens, or get reflected from an optical device that causes them to converge at a point. Causes them to converge at a point, and there's no A in converge. Causes them to converge and intersect at a point. So they're actually really honest to goodness intersecting. I can't spell today. Intersect at a point. Okay? So they actually converge and intersect at a point. So light from a common point passes through or is reflected by an optical device that causes them to converge and intersect at a point. And when that happens, what's formed is a real image. Under virtual, in the same one, it's light rays from a common point pass through or are reflected by an optical device that causes them to diverge and appear to intersect at a point. These guys do not really intersect like up here in this diagram. That's why I said most of the images that you would be used to would be virtual images. So all the images you would think of with respect to a mirror would be virtual. Okay, so these ones, light from a common point, pass through or are reflected by an optical device that causes them to diverge and appear to intersect. Now, there are two really easy ways to tell if an image is real or virtual. So these are like characteristics of real and virtual images that we're listing. A real image is always, 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 always inverted. And in case you don't know what that means upside down. A virtual image is always erect, or in other words, right side up. You in the mirror, in the bathroom, in the morning, your face is always right side up. You don't look in the mirror and see your feet, although that would be kind of entertaining. Okay, it's always a virtual image. But if you want to think of a real image and think you haven't seen one, if you think of a camera, now a camera with film, and I know they are hard to find, but it probably works the same with the digital. But a camera with film, or the image is formed by the camera lens on the film in behind the lens. And if you were to look at old negatives from your mother or grandmother's age, you would see that the images are actually upside down. Or if you've ever seen one of those old slide machines, like the carousels, where you had to put the slides in, you always had to put them in upside down, and that way the image would be right side up on the screen. Our eye is also forms a real image. The image on our retina is upside down. The optical nerve carries it to our brain and flips it over. So real images are always inverted. Virtual images are always right side up or erect. The other really easy way to tell if it's real or virtual is that if it can be formed on a screen, if you can put a screen in the spot where the image is and the image will form there, then it's real. If it cannot be formed on a screen, it's virtual. So I just gave you a few examples cannot be formed on a screen, right? I talked about the film on the camera, that's the screen. The retina of our eye is the screen. In the old slide projectors, where they got projected on, that was the screen. The way the projector that our smart board is set up for, you see the image on the smart board, that's a screen. Those are all real images. Now the smart board one is right side up because it's a double lens, okay? But virtual, think about your bathroom mirror. There is nowhere you can put a screen behind that mirror that's going to form your image, right? It's not, I hate to tell you this, but that image isn't really there. And so there's no spot that you could possibly put a screen that it would form the image on there. Okay, so examples here would be overhead projectors, cameras, your eye, and examples here would be your bathroom mirror. Another one would be a magnifying glass. Okay, those are virtuals. So real and virtual images, and these are the characteristics for them, whether we're talking about mirrors or lenses. Okay, these are the characteristics for real or virtual images with mirrors and lenses. All right, so we're now going to start, after that little intro, we're going to start with images formed by reflection. In other words, formed by mirrors. And generally, there are two different types of mirrors. The first type is called a plane mirror. And by plane mirror, I do not mean the type of mirror that's in the bathroom of a plane. I mean the type of mirror that is all in one plane. In other words, a flat mirror. Okay? So it's the mirrors that you're used to. And so where you look in and light reflects off, following the law of reflection, and you follow them back, and you see your image. Okay, so the law of reflection from grade 11 holds. And the law of reflection simply says the angle of incidence, theta I, is equal to the angle of reflection, theta R. And it's always measured with respect to the normal, the perpendicular line with the surface. So the angle of incidence is equal to the angle of reflection, if I could just draw my normal at the right spot. Okay, and so in the next video we'll look at characteristics here.